We are Group 8, and today we'll presenting a research entitled Factorial Design Analysis of Modality Shift and Study Hours on Civil Engineering Quiz Performance. As we all know, many universities including Mapua now use both online and face-to-face classes. Because of this, students have to constantly adjust to a different learning environments. At the same time, every student has different study habit, and these differences may affect their academic performance. Our research focuses on understanding how these two factors work together and whether they influence students' quiz performance. Civil engineering is a demanding program that requires students to understand concepts deeply and solve complex problems. That's why both classroom learning and independent study are important. Many previous studies have already shown that learning modality and study habit affect student performance. However, most of this study look at them separately. Our study wanted to answer the question different. Does spending more time studying help students perform better, regardless of whether they are learning online or face-to-face? Or does learning environment still make a difference? By answering this question, we hope to provide useful insight for both students and educators.
To address this gap, our study set out to accomplish three clear objectives using a controlled 2x3 factorial experimental design. First, we wanted to evaluate the standalone main effects of shifting learning modalities and weekly study hour thresholds on students' quiz scores. Second, we analyzed if a joint interaction effect exists between these variables using a two-way ANOVA framework. And finally, we aim to develop a predictive response surface model to visually map out these performance trends. Our methodology targeted second-year civil engineering students at Mapua University, specifically tracking their performance in structural mechanics courses during term 3 of academic year 2025 to 2026. We gathered a balanced sample of 150 valid student records, which translates to exactly 25 replicates across our 6 treatment cells. Independent study hours were carefully sorted into 3 operational thresholds: low, medium, and high, completely isolating this specific engineering discipline to prevent data contamination from external course variation.
Our statistical data analysis, we leverage MATLAB statistics and machine learning toolbox using the multivariable ANOVA function executed at a significance level of 5%. We tested 3 distinct sets of hypotheses, evaluating whether true performance means across shifts were identical, whether scores remained stable across the 3 study hours tiers, and crucially, whether the interaction coefficient between delivery method and time invested was equal to 0. The empirical data revealed that both main effects are highly statistically significant, with p-values well below our alpha threshold. As shown in this data summary, there is a progressive increase in quiz performance as study hours advance from the low tier to the high tier. However, face-to-face instruction consistently yielded higher performance thresholds overall, showing a distinct edge over the online modality across all tracking metrics.
The core finding of our paper lies in the highly significant interaction effect, where f equals to 17.62 and p is less than 0.001. As you can see from our interaction plot, the lines are distinctly non-parallel. While increasing study hours improves performance in both setups, the positive slope is significantly steeper during face-to-face weeks. Our ordinary least squares regression model, which explains over 91% of total variance, mathematically confirms that the academic return on students' independent time investment peaks when supported by an in-person learning environment.
This means that instructional delivery and independent study hours function as complementary, reinforcing educational forces rather than separate influences. The rigorous problem-solving inherent in engineering benefits heavily from real-time instructor feedback and classroom engagement, making independent study hours much more efficient afterward. Practically, our 92% accurate predictive model provides a valuable early warning tool for instructors to identify at-risk students before their performance declines significantly. In conclusion, our primary objectives were fully achieved. We confirmed that instructional delivery and student study behaviors jointly influence academic success and should be planned together. Moving forward, we recommend that universities integrate structured study planning workshops within civil engineering curricula. Future research should scale this model across multiple universities and incorporate longitudinal variables like learning motivation and digital literacy. Thank you for your time and for listening.